Hello everyone. This video would focus on rewriting radical form to its equivalent rational exponent form or fractional exponent form. Before we go farther, please feel free to check out the description below for the link of the other series of topics related to radical form or rational exponent form. Before we dive into this example right here, let's have a review on the notation for radical form and the rational exponent or fractional exponent form. Please remember that the notation that you see right now is in radical form, and this is read as the nth root of b raised to the power m, where our b raised to the power m is our radicand. In order that we can change this to its equivalent rational exponent form or fractional exponent form, this becomes b raised to the power m over n. So please notice that the index we have for the radical form becomes the denominator of the exponent of the rational exponent form, while the exponent of the base, which is m, becomes the numerator of the exponent in rational exponent form. To better understand this notation that we have right here, let's take some examples. Okay, going back to the example that we have right here, we remember that this is read as the fifth root of y. Now others are going to say, oh, but there's no exponent for y there. Please remember that there is an invisible exponent of y, which is 1. So then we can go ahead and say that our m is 1 and our n is 5. So that we can go ahead and rewrite this as y. So the base here is y, so I write y. And that would be raised to the power of the exponent of the base, which is 1. And then that is over the index, which is 5. So this is the rational exponent form or the fractional exponent form of the fifth root of y. Now let's take another example. Okay, in this next example, this is read as the cube root of 8x squared. Now, please remember that this exponent 2 here is only for the x. It doesn't apply to 8. The reason for that is there is no parentheses that puts together the 8 and the x. So again, the 2 is only for the x. But we remember that this whole thing here is actually raised to the power 1. So we can go ahead and put them all raised to the power 1. So that we can go ahead and rewrite this as 8x squared. That is the base of the radicand. And this is again raised to the power. We have to write the m. Our m is 1. And then our n is 3. So this whole thing was raised to the power 1/3. Now we can still simplify this further using the power of product rule property of exponents. We can go ahead and distribute this 1/3 to each of the parts inside the parentheses here. So this would come out 8 to the power 1/3 times x to the power 2/3. The reason why it's 2/3 is because 2 times 1 is 2, and then we have denominator of 3. Please remember that this 2 here has an invisible denominator of 1. So 2 times 1 is 2, 1 times 3 is 3. We can simplify this further. This 8 here can be expressed in exponential form. That is actually, if we multiply 2 3 times, that's actually equal to 8. So we can go ahead and write 2 raised to the power 3. That's actually 8. And again, this whole thing was raised to the power 1/3. So 2 times 2 is 4. 4 times 2 is 8. And that's how we got 8 here, 2 raised to the power 3. And then the 1/3 is the exponent of 8. And then we have this other part here, which is x raised to the power 2/3. Now we remember again that the exponent, or in this exponent 3 here, the invisible denominator is 1. So that we can go ahead and simplify this further. This would come out 2 raised to the power. That's going to be 3 times 1 is 3 over 1 times 3 is 3 times x to the power 2/3. And then 2 raised to the power 3 over 3 is pretty much 2 raised to the power 1 times x to the 2/3. And so the final answer for this would be 2x to the 2/3. So this is the rational exponent form of this given radical form up there. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So this is read as the square root of 9xy to the 5th power. Now we remember again that this power or this exponent 5 is only for the y. It doesn't apply to x and the 9. And then we also remember that our index here, if it's not written in there, that's an invisible 2. So I put that it's invisible 2 right there. So that we can go ahead and say that this whole thing that we have here, 9xy to the 5th is raised to the power 1. So that we can go ahead and rewrite this as 9. Our base here is 9xy to the 5th power times, we remember that it's m over n, or the exponent of the radicand over the index. So that would be raised to the power 1/2. And so we can go ahead and use the power of a product property for exponents. So each of these is going to get the 1/2. And so we are going to rewrite this as... Okay, so what I did here was that 9 is going to get the 1/2, and then this x is going to get the 1/2, and then the y here is going to become 5 over 2, because again, remember, this 5 here has an invisible denominator of 1, so 5 times 1 is 5, 1 times 2 is 2, so that we can go ahead and simplify this further. Now we remember that this 9 can be written as 3 squared. That means 3 raised to the power 2 is 9, and this whole thing is again raised to the power 1/2. So 3 times 3 is 9, and that's the 9 right there, and this 1/2 is the exponent of 9. And so we go ahead and write the rest of them. Okay, now we are going to simplify this further. We remember that this exponent 2 right here has an invisible denominator of 1, and so this expression becomes... that's going to be 2 times 1 is 2, and then 1 times 2 is 2. So that would be 3 raised to the power 2 over 2. So I'm going to go ahead and write that down here. So this is the equivalent rational exponent or fractional exponent of the square root of 9xy to the 5th power. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example. Okay, so in this example right here, this is read as the cube root of x squared y. Again, we remember that this squared here is only for x. It doesn't apply to y. So that we can go ahead and say that this whole thing here is actually raised to the power 1. And so we can go ahead and rewrite this in exponential form. So we write the base first. So that would be x squared y raised to the power, the exponent of the radicand is 1 over the index is 3. That's raised to the power 1/3. And we're going to use the power of product property for exponents. This 1/3 is going to go to each of them. So this would come out. Okay, so this is the equivalent rational exponent for the cube root of x squared y. So please notice that this 2 here has an invisible denominator of 1. So 2 times 1 is 2, 1 times 3 is 3. And so we have 1/3 for the y. And so this is the equivalent rational exponent. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. So this problem is read as 7 times the 5th root of a squared b cubed. So how do we simplify this? Please remember that the 7 is outside the radical symbol. This is the coefficient of the expression. So we remember that this whole thing here, the radicand, is raised to the power 1. And so we can go ahead and rewrite this as 7. The 7 is outside the radical symbol. That is 7 times. We write the base, which is a squared b cubed. And then we are going to write the exponent for this. Remember that the exponent for this would be the exponent of the base of the radicand, which is 1 over the index, which is 5. So this is raised to the power 1/5. So that we go ahead and use the power of a product property for exponents. So each one is going to get this 1/5. So this expression is going to come out. This would be 7. And then we have a raised to the power. Remember, this one has an invisible denominator of 1, and this one has an invisible denominator of 1 as well. So this comes out, 2 times 1 is 2, and then 1 times 5 is 5, and then the b, it would be raised to the power 3 times 1 is 3 over 1 times 5 is 5. And this is the rational exponent form for this expression that we have up there. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example. Okay, so we go over the problem here. So this is an example of a nested radical expression. So that means there is a radical inside a radical. So what we would do here, since at one look at this, others are going to freak out like, oh, I don't know how to do this, because there's like a lot of radical expressions. So what we would do is we cover, there's actually 2 equations here, or 2 expressions put together, the inside and the outside expression. So we are going to start from the inside, we go outside. And so we can cover this 5th root here so that it doesn't mess up with the whole thing. So we cover that first and simplify the ones that's inside. So in here, our 4 is the coefficient, and so we can go ahead and rewrite this as 4. So 4 is outside the radical, so I write 4 here. And then this, remember that this whole thing here, or this radicand here, is raised to the power 1. And so we can go ahead and rewrite this into its equivalent rational exponent or fractional exponent form. So that would be x squared y. And then this is raised to the power. The numerator will be the exponent of the radicand. That is 1 over the index, which is 3. And this is the inside expression. So we can go ahead and put this inside a bracket. So again, this is the inside expression. Now we go to the outside expression. Now we remember that this whole thing here is the radicand of the 5th root. So that means this is raised to the power 1. And so this whole thing here will be raised to the power 1, which is the exponent of the radicand, 1 over 5, which is the index. So this is how we simplify a nested radical expression. So what we would do now is we are going to take the power of a product property of exponents. So these ones are going to get the, we start from the inner part. This one's going to get the 1/3. So our expression would come out. Okay, so what I did here was that, please remember that this exponent 2 has an invisible denominator of 1. So 2 times 1 is 2, and then 1 times 3 is 3, and then we get 1/3. And this 1/5 is the exponent for the whole thing. Now, what we would do is we are going to use, again, the power of a product property of exponents. So each of these is going to get the 1/5. So our equation would come out. So this is the equivalent rational exponent form for this radical form right there. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!